Next topic is implementation of Prim's algorithm. Now in Prim's algorithm, what you have to do, we have to take basically two arrays have been maintained. One is a key value, another is a predecessor array. So what we have to do, we have to initialize, we have initialized your priority queue has been maintained by giving all the starting vertex as key value as 0, remaining as infinity, and generating the entering all the vertices of the graph within the priority queue, maintaining a priority queue for the same based upon the key values, and the minimum priority queue will be the at the root of the heap. Priority queue implementation using heap is being utilized here. Now once A is being removed, first of all we have to extract the minimum value, extract min function of the priority queue implementation using heap. This will remove A0 entry, and this will be replaced by I infinity value, because last is being replaced by the first entry in the priority queue implementation using heap. So this entry will be removed and this A will be added to the final answer, and all the vertices adjacent to A that will be updated. Now A adjacent to A is B, so B entry will be updated to 4. So once your B entry is being updated to 4, so B comma 4, this entry will come because this entry is smaller than this one, so there will be swapping of I and B4 entry like this, and this B entry, because the predecessor of B, that will be equal to A, and the key value now will be updated to 4. Similarly, what next is adjacent to A is H. So H was earlier infinity value, if you carefully see. So this infinity value is larger than that of AH weight. So what this will be updated to 8, and this entry will be updated to A. And because that H entry was earlier infinity, now it has become equal to 8. This will come at the upper end somewhat at here after swapping. D will come here, then I, this will become here with D, there will be I, the entry will become H here. So this will be the final output after this. Next comes the entry that is called, now B will be at the top of the queue. Now next step is removal of the element, minimum priority queue element. So minimum element with the minimum key value from the priority queue implementation using heap, that is B is being removed. Now once B is being removed from the priority queue, this will be replaced by maximum of, minimum of these two. The H will take care of this, H will come at the upper end when this is being removed, and to settle down H, the further E entry will be, sorry, D entry will come out here, D comma infinity, because once you remove B comma 4, last entry will be replaced by the top first entry which is being removed. This D infinity is greater than H8, so this D infinity will come here, and H comma 8 will come at this end. So this updation of this priority will be done. H comma 8 has come. Now the adjacent two values to B are two values. One is C. Now C entry will become, because earlier C is infinity, the C will be replaced here by 8 value, because B to C distance is 8, and this nil value will be now replaced by B. Now when we are saying C as 8 entry, earlier it was infinity, so C comma 8, this will be updated as such without any updations in the priority queue implementation using heap. And one more thing which is adjacent to B, the element here is H also. The distance of B to H is 11. But if you carefully see, the earlier the entry was 8, which was already smaller, then no change in the entry for H has occurred for this case. Now the next element which is to be removed is H, depending upon the minimum value. If you see the minimum value out of this, this has been processed, this has been processed. These are the possible entries which are there. And if you see carefully the heap structure, from heap structure, topmost element, that is H, is being removed. Once you remove the H, this is replaced by the entry G, G comma infinity. But G comma infinity, if you say it has got larger value, so this will be replaced by C8. So G infinity will come at this place, and C comma 8 will come at the upper end, like this. H will be part of final list. Now if you see the adjacent two values of H, adjacent to value of H is GH, that is G, this value entry. Earlier G entry distance was equal to infinity, now it will become equal to 1, and it is the predecessor of this will also become equal to H. Because we are changing the entry of G, earlier it was infinity, it has become now equal to 1. This is going to disrupt the priority queue heap structure. So there will be swapping of this value. C8 will come here and G1 will come at the top end position in this case. C8 will come here and G1 will come at this position. And further, if you go for the another entry adjacent to value of h, that is h value is another value is I. If you see the entry for I, this is also infinity. So this will be updated to 7 because h to I, that is 7, and nil entry will be replaced by that of h. When you are updating I entry, earlier it was I comma infinity as I comma 7. So this I comma 7 is going to violate the property of heap structure. So this will be replaced by I comma 7 will come at this position and d comma infinity will settle down at this position. So further there won't be any further updation of the priority queue in this case. So I will be coming to this. Now after next is pick the topmost after adjacent to of the h has been entered. Pick the topmost entry, that is remove the element from the priority queue based on the minimum key value. The element to be removed is g comma 1. When g comma 1 is to be removed, this is replaced by the last entry, that is f comma infinity. F comma infinity can't settle down. The minimum of this will be taken. F comma infinity will come here and I comma 7 will go here. If you are going to delete g out of this, so I comma 7 come here and f comma infinity goes in this direction. Now g has been removed. Once g has been removed in this case, so what you have to do next here is, that is, you have to now go for G to F, that entry, that is 2. And if you see the entry here, this is entry is infinity and this entry is nil. So this entry will be equal to G and this entry will be equal to 2. When the entry of F is now 2, F is 2 here. Now this entry is already smaller, so this will be replaced by I comma 7. This will become F comma 2. This will become equal to I comma 7 here. The entry will be updated like this. Now once you have got it G, and adjacent to G one more is, that is called I. I, if you see carefully, I with respect to earlier the value was 7, but G to I distance is 6. So this will also be updated to 6 and the value here will be G. So this value is being, because this I value is being updated to 6, no change in the position because this is already smaller than that in terms of priority queue. So this I is also being updated. Now next element to be removed once G adjacent to have been settled down, the next element to be removed is the topmost element in the priority queue, that is a minimum key value, that is F. Now when F comma 2 is being removed, this is replaced by E comma infinity here. But E comma infinity value is not a proper place for the same. So this will be replaced by I comma 6, because I comma 6 is smaller than that of C comma 8. So this E comma infinity will come here and this will be taken, or this place will be taken over by I comma 6. So F comma 2 is being removed and this value is being, the latest position of priority queue using heap will be this one. Now if you carefully scan for this vertex F, adjacent to F is C, whose edge weight is 4 and the vertex key value is 8, which is larger than that of edge weight. So this value will be swapped here, CF value. So this value will now become equal to 4 and the previous of this will become equal to F. Because the entry of C earlier it was 8, now it is becoming equal to C comma 4. Now there will be updation. This I6 will come here and C comma 4 will come at this entry's position. After this, next step, C to D, F to D, sorry, adjacent to F, one more element is there, that is F to D. If you carefully see, the entry for D is infinity. The entry of D, as you know, it is infinity here. So what you have to do, the distance of F to D is 14. So this will be operated by 14 and the predecessor will be here F. Adjacent to F is C, whose edge weight is 4 and the vertex key value is 8, which is larger than that of edge weight. So this value will be swapped here, CF value. So this value will now become equal to 4 and the previous of this will become equal to F. Because the entry of C earlier it was 8, now it is becoming equal to C comma 4. Now there will be updation. This I6 will come here and C, 4 will come in, at this entry's position. After this, next step, C to D, F to D, sorry, adjacent to F, one more element is there, that is F to D. If you carefully see, the entry for D is infinity. The entry of D, as you know, it is infinity here. So what you have to do, the distance of F to D is 14. So this will be operated by 14, and this the predecessor will be here F. As this entry is being updated to D, 14, this will be swapped at the upper end, and this will come E, infinity will come here, and D, 14 will be positioned at this position. So D, 14 has come here. Then adjacent to F, one more entry is there, that is F to E. Now F to E, if you clearly see the entry, this entry is infinity, this will be replaced by edge weight F to E as 10. This value will be again replaced by the entry F, predecessor of this. And as you know, if you're changing the entry E infinity to E, 10, so this this will become E, 10, and there is no change in the position of this element because it is the element of this position. This element will be changed because 14 is greater than 10. So D, 14 will come here, E, 10 will go here, and this further because this is the final priority queue status, and this is the final value. After this, the smallest, because all the adjacent to F have been explored, the next element to be removed from the queue is C. This will be replaced by the last entry, that is D, 14. So D, 14 will come at this position. Now the just can just key adjacent to C elements which are there still in the priority queue are D only, and D, then I is there, okay, I is also there, and one more is there, E is there in the priority queue. Adjacent to C, if you alphabetically see, then first is D. So C to D, if you see the entry for this D, this is 14, but C to D distance is 7. So the value will be replaced here as C, this entry, because this entry of D is being changed to 7 now. So there won't be any change in the position because 6 is smaller than that of 7. This entry is being changed. After this, the next entry will be C to I. C to I entry, if you say the entry of I, that is equal to 6. The edge cost from C to I is 2, so this will be replaced by 2. And this entry will become the predecessor of this will become equal to 2, because the entry of I is now changed to 2, no change in the priority queue further positions. After this, the next, once the C values have been adjacent to values have been stored, next smallest element in the priority queue is I. So I is being chosen. So when you're picking the I, this will be replaced by this entry D is 7 because it's smaller out of this 10 and 7. This will be replaced by 7. And try to find adjacent to I. Now adjacent to I, no one is remaining because all of them are in the already are not a part of priority queue. We have to skip just I, print this I, and as such, the next element to be removed will be D. Now D is being removed. Adjacent to D, which are there in the queue, are the element E, 10. Now this element now will be replaced by, because adjacent to D, this is the element, so this element will be replaced by the value 9, and the predecessor of this will be equal to not D. This will be exchanged like this. So the last element to be removed is E. Nothing is left in the priority queue now. This is the final answer. Now how to get the final answer for the minimum spanning tree, how to get the edges? Just pick the edges as such. AB edge, BA edge, CF edge, predecessor and vertex only. With DC edge, ED edge, FG edge, GH edge, HA edge, IC edge. Now how to find the cost of the minimum spanning tree? Find the sum of all these edges. You will get the final cost for that minimum spanning tree using Prim's algorithm.